Howdy, Cape Codders. Welcome to the Scannell Agenda. Today's date is October 23rd, 2013. This is show number 8. I'm going to continue belabor the point about an evacuation system for the Pilgrim nuclear plant, because that's what I'm into, and I've been working on it for 6 days now. And I know this is very short notice for me to be putting a system together, but that's what I've been doing. So, all right, I'm going to just continue to talk about aquaculture gear and its dual purpose for evacuation. Now, this is killing two birds with one stone. So our aquaculture gear, in other words, a floating marine laboratory, or a factory ship of some kind that handles gear that's close by that can be made ready to ship a lot of people. That seems to be the general theme for the evacuation, because we're not going to be able to cross the bridges, and we've got to get out to the north or to the west, just in case we have a nuclear plant failing. And so we have a kill zone. The kill zone will trend one way or the other, and we have a compass rose here. That's called a compass rose. So the wind will blow. Let's say this is north, and this is east. So this is northeast. So if you have a northeast wind, the wind is coming from the northeast. Okay, could be coming from the east or from the southwest. We have a lot of prevailing winds here. And these contingencies will all be developed. And at any minute of the day, we will be able to go to an application and see what the contingency plans are for that particular minute of the day. So the concept is to have a contingency plan and a forecast going out, and then to use it if we need it. And if we don't, that's wonderful. I mean, how do I know we're going to need it or not? I mean, we consulted the fortune cookie, right? That's all I can tell you. I mean, your guess is as good as mine. I don't work at the nuclear plant, so I don't have opinions about such things, other than, you know, I know about old boats. All right. So the floating marine laboratories can be many on the Cape, and these are boats that specialize in being a hatchery for fish and shellfish. So these can be very productive little boats. And they can be good-looking boats. There's no reason why they have to be ugly. But here's a design for a floating marine laboratory with open bottom tanks. So I probably have, I don't know, a lot of these designs now. Here's a design for a 165-foot Hickman. It's called a Hickman as a boat style. And it's a floating marine laboratory. It's similar to a Boston whaler. They're fast and they're somewhat seaworthy. And so with this particular 165-foot Hickman, it's we roll out the innards fast. That is, there's a bunch of aquaculture gear that is designed to just pull free and roll out. And you would need to do this for drills, and you'd need to do this for the real McCoy if we have trouble. And we could also at the same time roll in some seating and or pads or little decks and things like that, because we're going to be jamming people in these boats. Now this particular boat is one of the first to leave, so it's a high-powered craft. It would carry your kids. And so I'm giving kids the big priority to get the kids off the Cape. Here's another fast one. And this design is based on a kind of a tin can, like a sardine can. And it goes 40 knots with a pusher boat. It's got a pusher boat that, the pusher boat here is a 70-foot modified Hickman, and it's overpowered, and it just happens to be a lobster boat. And it's got big twin engines. It's overpowered. It's way overpowered. But it's not a bad deal for the lobstermen working the boat. And not a bad deal for us either. Now we have the Skedaddle. I named this boat Skedaddle because it's only going to carry enough fuel to go a certain distance, and then there'll be some pre-positioned fuel because your people weigh a lot. So you don't want to be carrying fuel to go, 600 miles. You want to be carrying fuel to go, maybe 100 miles. So we're going to shed extraneous gear, load with people, and this, I'm going to say, is all going to this is all going to happen in about 20 minutes, and people will actually be walking to these boats as well. So I'll just hold this here for a minute and talk about that some more while this can be focused on. This is the aquaculture floating marine laboratory. It's just one of many designs. These are engines. These are go-fast turbocharged diesels here, so there's 4 of them. Now they don't get used for the aquaculture operation. They're just waiting, like a fire engine waits for the eventuality. So this is 130 foot, and then you've got this pusher boat with these big Arneson drives, and it's very fast, very fast. It's a very, very fast and powerful lobster boat. So that would be a modified Hickman, and it would kind of look like, the whole thing would look like that. But this gizmo here, you wouldn't need it for the aquaculture operation, obviously, but this would be, a bunch of these, like 6 or 7 or 8 of these would be right here from Yarmouth into Chatham as your factory, not factory, excuse me, as your floating marine laboratories, producing valuable shellfish and fish. It's worthwhile. They'd be waiting here for the eventuality. Hopefully we won't need them, but if we do, then good. We'll have it. Now here's an evacuation system that would be dropping people from Bass River. So it's a 5-pipe gear drop ready evac for Bass River. And with these, what they are is they're oyster gear hangars, but they also carry people right out of the river. People from some of the nursing homes in Dennis and Yarmouth that can access Bass River. And we may have a conveyor belt system to load pods, which I could get into, pods for evacuation. So you put your old folks and infirm people into the stretchers on pods. These are all ready to go. And then you load them into the shallow draft 5 pontoon vessels, which, strap a couple outboards onto those things. And then you've got people moving out of Bass River. Now, what's the advantage? Why not just load everyone? You can't. You have to have several loading points that are inland if possible, because you'll choke. Everyone will choke. There'll be choke points. It won't be doable. And in 20 minutes, we've got to get off the Cape. That's the goal. 20 minutes. Lights out. So that's pretty, high quality wood glass pontoons, and they're light. So Parker and Swan River can have this same system if we design the rivers to go deeper. I've got designs for that. That just happens to be another one of my projects, is the deepening of Parker's River and Swan River. And a lot of ancillary things go with that. So here we have a aquaculture factory ship or barge, or floating marine laboratory or barge. And this one's bigger. This one's 400 feet long, and it's got 3 pontoons, 1, 2, 3. And it's ready to really rock and roll during the first 50 miles. It's going to be quick because these pontoons are going to have compressed air, which will help to propel the vessel. And the main deck, which is here, is designed to jettison the equipment and load with people. And then you've got, you know, 3 main decks, 3 other decks above that, and then the outside areas. Now these will have to be positive pressure as well. If we get caught in the kill zone with this vessel, you'll be able to use the compressed air to breathe. You'll be somewhat safe, I believe, if you've got a positive pressure system that you're loading a few thousand people, maybe as much as 7,000 people into that one boat. Of course, won't be first class, so complain to someone else. It's better than getting caught at that canal and, you know, inhaling all those fumes. Now, if we are going to be running traffic out of the canal area, and we will be, I'm sure, we can use positive pressure systems that are pre-planned and waiting to go. So you get into these double and triple, doubles and triples, a trucker would call them, trailers. And these are the priority rigs that run right through, and the police just get them right through over the bridges, and they have the lanes cleared for them. And so these are ways to move hundreds of people across the bridges fast. Your low priority are your single car with 6 people in it, and your high priority is your truck with 300 people on board that truck in a positive pressure air system, so that you're not breathing in the kill zone, which we may have to cross over through a kill zone and into some fresh air. So we'll have these systems in place. All right. So very important, the kill zones. Now, the tripe system has given me a lot of experience designing pipes that carry compressed air and oxygen-rich compressed air and hydrogen. These are multi-use pipes that carry energy from, it's a design, it's a machine. It's not been built yet, but it's a design for a machine, so that's what it is. Now this tripe system, which stands for track pipe, as I've explained earlier in the first show, this will need some main pipes coming on shore, let's say from Georges Bank, and using the Georges Bank mega mill windmills, we'll be able to ship a lot of compressed air and hydrogen inshore. That's valuable green energy. But then I started working on this system, so I said, okay, I'm going to bring one of my main lines, and then there are several main lines that'll be coming on shore. I'm going to bring one close by to the Pilgrim, so in the eventuality we'll design the pipe with a dual purpose. We'll use that as an exhaust pipe, and we'll work on ventilation systems or tent systems that will hopefully capture a lot of the poison gases coming from the Pilgrim plant, if it happens, and depositing all that gas perhaps 50 miles east of Monomoy or Nantucket, or further. Or compression of those gases is possible too. If we have a working tripe system, we could just send those gases 900 miles east. Now, that would save us a lot in property values and lives. So you want to weigh the pipe against the risk, and you want to delineate the risk, and you want to cost out the pipe. And if the pipe is being used anyway for another purpose, that just adds value to that pipe. Why would it add value? Well, it would add value from the operator's perspective, from Entergy's perspective. It would lessen, lessen the insurance cost. If you can capture those gases from a meltdown or another different form of an accident, that would lower your insurance. Assuming we are okay with talking about insurance for a nuclear plant, which we haven't been okay with that since 1957. I've always had the main complaint that, nuclear plants are not insurable, so, I have my opinions about nuclear energy, but the insurance thing is kind of big. Here I have a marine laboratory that's an aluminum evacuation boat, possibly built by Gladding and Hearn. Goes 20 knots. It's large, it's light. We dump our tanks, and we load it with sleeping mats and pull down decks so that we can jam it full of people, and the boat leaves in 20 minutes. That's the plan, because if you are in the kill zone, you want to get right out of there. So this would be a 180-foot boat with pontoons, and that's based on a 45-foot high topsides with pontoons. It's aluminum, which we wouldn't need the aluminum, of course. We would not need the aluminum to build any kind of a marine lab, because aluminum's expensive, and it's light, and it's strong, it's good stuff. But what we'd actually be doing is we'd be killing two birds with one stone. We'd be designing these aquaculture vessels as evacuation vessels, and that might actually help even pay for them too. So you design this stuff so that you can dump the tanks and you can lighten up and get rid of the gear. It's designed to get rid of the gear fast, and that'll be part of the drill, okay? And then basically your marine laboratory turns into more or less a speedboat. Here I have a deep hole loading wharf with a pier. Now, Deep Hole Road is off of Harwich, so that you've got some deep water. This is the beach, and now you bring in these 40 by 40 foot aquaculture rafts, and then you piece them together quickly, and then you've got docks out here for the bigger boats who were just called in from offshore or New Bedford, and they are now arriving, and loading. So, all kinds of things happening at once to do this, to evacuate Cape Cod by sea. So this would evacuate Chatham, South Chatham, and the fishermen would be charged with, getting this work done and getting it done fast. Probably your fishermen, your aquaculture people would be drilled, ready. Pre-plan against communications gridlock, police, fire, civil defense, CB radios, communications, listings on houses clear, we're out, by the street monitors, knowing who's out, so there's no panic and people going back into the kill zone. Cross canal helicopter pod carriers, you load your pods, you bring in your helicopters that carry the pods back and forth. Children first policy. This plan, our society needs champion planners. And I think we should have a contest, a planners contest for this project. I wonder why I think so. Well, I might win. I'm jumping on this. But these ideas are public domain. They're on the table, so have at it. All you fire chiefs and fishermen and harbor masters, start thinking about this. People that work in boat yards especially, aquaculture workers, transportation workers. Okay, clean air and water equals survivability, those systems. Camp train, this is something new. Camp train positive pressure units. Expansion of the train system for this purpose wouldn't cost that much, believe it or not, to lay some tracks, and especially to lay some tracks in such a way as they have a double duty as camp and train. So they're campgrounds. So they've got some trailer standards. We used to have the line used to run here, as it's shown, into Chatham. And we could run a line to Deep Hole and circle it back out so that we could actually, run a line pretty well across Bourne and Sandwich and connect in to the existing line and then loop it back. So if you have thousands of people from this coast here that want to get put on trains, you'd have the trains waiting, and they would also be doing double duty as little camp units, and you could really cram these trains full of people. That would save your roads from all the congestion too. You want to maximize your ability to move people really fast. Boat trailer conversions. We could go, people with boats could go with some standard boat trailer conversions so that you can put one of these positive pressure pods onto the boat trailer. And so you'd have one pickup truck, and that would be carrying these positive pressure pods. And air evacuation at Hyannis Airport. Okay, that's another scenario. And not just Hyannis Airport, but you've got Provincetown Airport, Chatham Airport, Nantucket Airport, Martha's Vineyard, Marston's Mills, and you've got Otis. You've got your commercial carriers, which are pretty small, but I would propose that we expand with this contingency shaping up, expand the Hyannis Airport so that your airfields can be used for your large commercial jets can come in and pick up, and the C-130s, the military craft, could probably be here pretty quick. Some C-130s and be able to cram some people. So that's an air evacuation. Air, by sea, by land. The worst case scenarios. So back to the trains, 5 at 30 train cars await. So you've got these trains that are kind of rigged to be positive pressure and rigged to carry a lot of people, but also to be used as train yard camps for the tourism and such. It's 495 Canal Bridge, Plymouth to Cape Cod, evacuation. Depending on the wind, you're going to get people in Plymouth that are going to pinch, as I call it, and then they're going to want to come south and then east to avert that kill zone. Everything is to keep people out of this kill zone of polluted air, the radiated air. So southeast Mass and New Bedford, these people may be coming east with this scenario. Or we may be going, you know, by sea right across Buzzards Bay in these craft. Because these craft that are located in Harwich can easily shift and come around through Woods Hole and be ferrying people across Buzzards Bay. Now, if the kill zone is hitting Provincetown, then you'd want your pre-positioned boats in Provincetown to load up and come toward the canal, because they couldn't cross. Most likely they couldn't cross toward Boston, but they'd be able to come and stay out of the kill zone in Truro. And if you only have 30 minutes or 20 minutes between the bad air coming from Pilgrim to Provincetown, you want to have the boats ready to go right there. And then your rest of your people are going to be swept. The kill zone will sweep the people away from it down into here, and you'll get people moving via boats and via trains, via the roads toward Buzzards Bay. We won't be able to choke everything up at the canal here over these couple of bridges we have. And there are contingencies that we can use temporary bridges too. So positive pressure systems, freshwater reserves, helicopters for the kids, the Bass River evacuation. These are just, that would be a micro plan for the rest of the Cape. So, I mean, this just, and there's more, there's a lot more. I've got about 20 pages here. I'd like to get into meetings with firemen, fishermen, or a club of people would be good. You know, we can get into these little evacuation clubs, or call it what you will. Might be fun. I like it. I like the work. And I like brainstorming. And this is all pretty much brainstorming. Nothing to be ashamed of that you start a project. You know, I've been shamed quite often because I don't have all the details worked out on some project or another. I don't have that anymore. I just keep working on projects. So if the Pilgrim nuclear plant goes and we're ready for it, geez, we'll be ahead of the game. Thanks for watching the Scannell Agenda. So let's get on some of this stuff. As I said, the clock is ticking, right? Clock is ticking, so this might be a fun project. I know it's a disaster. Disaster planning can be fun. So thanks for watching the Scannell Agenda.